Welcome back again. This is Chapter 9, Section 5 of your note-taking guide video lessons. We've graphed circles, we've graphed ellipses. Now it's time to graph and write equations of hyperbolas. So, taking a look at some of these vocabulary words here. A hyperbola is a set of all points such that the difference of the distances between P and two fixed points called the foci is constant. So, with an ellipse, you had a foci, and the sum of the differences of the distances were the same. For hyperbola, the hyperbola looks something like this. Okay. The foci will be here and here, and this point here, here's a point, this distance, the difference between those points are the same. Here's a point. The difference between that point, and that point will be the same. So, hyperbola, it's the set of points where the difference the differences of the distance between the point and two fixed points is constant. All right, so foci are the two fixed points. Vertices. It's a point of intersection of a hyperbola and the line through the foci. So what you got now is you got a hyperbola, and right here, that is a vertex, that is a vertex. If you were to flip that over, you would have a vertical one there. A transverse axis is a line segment connecting the line segment connecting the vertices. And then the center is the midpoint of the TA, the transverse axis. Not quite as much as an ellipses, it's still going to be some of the same work. To fill this out here, you can see this is what the difference is between what the differences in the equations based on a circle and an ellipse. Here you're subtracting. It's equal to 1. You've got an A and a B, but you're subtracting. So if you have a horizontal hyperbola, it has some asymptotes at plus or minus B over A. And then the vertice is at A. If it's vertical, it's now instead of B over A, it's A over B, and it's at 0 plus or minus A. And since there's a sign difference here, this foci is actually A squared plus B squared. So coming up with the foci is should not be as difficult, because it doesn't matter where you put A and where you put B. So again, there you go. This is the center is at the origin for all of these. this would be a horizontal hyperbola. Therefore, the asymptotes are at B. The asymptotes here actually kind of form an X. And so the asymptote here, this one would be Y equals positive B over AX. And this one here would be Y equals negative B over AX. The vertices are at A, so whichever one, whatever the A is the vertice. And that's about it. Let's do some of these problems. This looks identical to something from 9.4. It's identical, except that there's a minus sign. So just like before, I do also want to point out something here. You know this is horizontal. You may not have picked this out. You know this is horizontal when the y squared is negative. You know it's vertical when the x squared has the negative sign. So here, the x squared has a negative sign. Therefore, this is a vertical asymptote, or a vertical hyperbola, I'm sorry. So you end up with this first. And of course, just like last time, divide everything by 324, and that gives us the equation y squared over 9 minus x squared over 36 equals 1. All right, so the minus comes second. Therefore, A, let me write it like this. So this really is y squared equals 3 squared minus x squared equals x squared over 6 squared equals 1. So our A value is always the first term, and it's the positive one. So our A value is 3. Our B value is 6. It's horizontal, so the B value comes first. So when it asks to identify the vertices, vertices are at A0. So vertices are at plus or minus are at 0 plus or minus 3. The asymptotes are B over A. Therefore, y equals B is 6 over 3x, or y equals plus or minus 2x. The foci, you need to use this right here, the sum of a and b squared. So since a is 3, so c squared is 3 squared plus 6 squared, that's 9 squared plus, not 9 squared, that's 9 plus 36, that should be 45. So c is plus or minus the square root of 45, which is approximately 6 point, plus or minus 6.7. So let's go ahead and graph this. Vertices at 0, positive 3, 0, negative 3. The focus So we just did this part. The focus is at 6.7. So the focus is at 2, 4, 6, about 6.7 here. 2, 4, 6, about 6.7 here. And now you could go ahead and graph the, just do your parabola, okay? The problem is, though, there is an asymptote that should follow this path right here, plus 2x. So it's up 2 over 1. All right, I made a couple mistakes here. I think I said that originally this was a horizontal. It actually is not. As you see this graph forming, you can see where the vertices are lying. And what you actually need to look at is, since it's on this y-axis, the vertices and the foci, it's actually not, these asymptotes aren't right. We have to flip it over. The asymptote is at y equals a over b. So that's y over is equal to 3 over 6x, which y is 1/2 x. All right. So now when I'm graphing this, all right, the asymptote, so like I said, go ahead, just sketch your hyperbola. But for the asymptotes, you end up forming something, x's that look like this. And now that will help you sketch your graph. So hyperbola does not touch those asymptotes anyway. All right, we're going to go ahead and keep plugging through some of these examples. Graph the equation, identify the vertices, foci, and asymptotes for this. It is already set up for you. It's a minus y. So since it's minus y, it actually is a horizontal one this time. Since it's horizontal, the x has the larger, is not negative. Therefore, the vertices, right, I'm not going to skip any steps here. Let's rewrite this in standard form. This should be x squared over 7 squared minus y squared over 3 squared equals 1. That means that a is 7, b is 3. That means my asymptotes are at plus or minus 7, 0. 1, 2, 2, 4, 6, 7. 2, 4, 6, 7. There's my vertices. Those are the vertices. Axis of symmetry. For this one now, axis of symmetry is b over a. And so it's 3 over 7. The c value, or the foci, is the addition of a and b, of the squares of a and b. So that becomes 7 squared plus 3 squared. That's 49 plus 9. That's 58, which is approximately 7.6. So now I have a foci at 7.6, man, which is right close to the vertices. So I'll just put it right there and right there. Asymptotes, 3/7. So we go up 3 over 7. So asymptotes help you get the general shape. Once you know the general shape, you go straight through the vertices, and you got your graph. I've labeled the foci, the asymptote, graphed the hyperbola, and done the vertices. All right, let's hope now that example 2, writing an equation for a hyperbola is a little bit easier. Write an equation of hyperbola with foci at -5, 5, and vertices at -4, 4. So we're looking at c squared equals a squared plus b squared. So we know some of this information. We know that since this is the vertices are always a. That means this a here becomes a 4 squared. The foci, the distance is 5, so that's 5 squared. So I've got 25 equals 16 plus b squared. I'm going to subtract 16 from both sides. 9 equals b squared. So my b value is plus or minus. No, it's not plus or minus. Just say it's plus 3. The b value is 3. All right. So my b value is 3. Now I just have to determine from my equation, first of all, which one has the negative. This is horizontal. Right? It's a horizontal hyperbola, which means the y squared gets the negative. And the y squared gets the negative. That also means then the a value is always just the first one here. So the a value is 4 squared. The b value is 3 squared. So my equation is this. This is your final equation. And again, we're going to do some more checkpoints here, and we'll have lots of problems to do in class. Write an equation of this hyperbola. All right. The vertex is always 0a. The foci is always the distance, which is c. So all I have to do, c squared equals a squared plus b squared. That's 8 squared equals 5 squared plus b squared. That's 64 equals 25 plus b squared. Now I subtract 64 minus 25. Gives me 39. So b squared is 39. I know that a is 5. Therefore, a squared is 25. I know b squared is 39. And I know that the equation should have the a first, the b second. It should equal 1. Now, we have to determine, is this x squared or is this y squared? Since the vertex is in the y spot, that means the a goes with the y squared. And there's your equation. So you can see you can very quickly come up with an equation for some of these things. All right, I think 2 more here. This is a diagram, or this is a multi-step story problem. The diagram shows a hyperbolic cross-section of a lamp. Write an equation for the cross-section of the lamp. The lamp is 10 inches high. How wide is the base? So it involves a hyperbolic lampshade, and it gives us some of the information here. All right, So a couple pieces of information here. We know that the vertex is always at A. So we know that A squared is 4. This part right here, we haven't talked about yet, but that's your B value. So B squared is equal to 16. So right away, you know that since this is a horizontal, well, you know this is 4, you know this is 16, you know it's equal to 1. You know since the vertex is in the x position, this should be an x squared and this is a y squared. So what we have here is now an equation. This really is the important part for this class, is knowing how to work with this equation or make this equation. So we wrote an equation for the cross section of the lamp. Done. Now the lamp is 10 inches high. How wide is the base? All right. So since we're dealing with pluses and minuses here, if it is 1, 2, 3, 4, 5 inches, 10 inches tall, that means my y, we want to know what the x value is when y is at 5 or negative 5. That part really doesn't matter. So we want to know what the x is when y is 5. So what is x? When y is 5. So all you got to do is take that number, take x squared over 4, minus 5 squared over 16 equals 1. You work this out, and you find out that x squared is approximately 10.25. You find out that x is approximately 3.2. Now, remember, that's plus or minus 3.2. That means from here to here, it's 3.2. And from here to here is 3.2. So you have to multiply that by 2 to get the width of the lamp. All right, here's the exact same thing. Write an equation for the hyperbolic section of a lamp in example 3. So we're using example 3 again. The vertices are at 3, 0, and the foci are at 5, 0. If the lamp is 15 inches high, how wide is the base? So we're going to have to follow these steps exactly. It tells us that the vertices are at 3, 0. So a squared is 3 squared, or 9. This time it doesn't give us a graph, but it tells us that the focus is at 5. So c squared for a hyperbola is a squared plus b squared. That means that 5 squared equals 3 squared plus b squared. So that's 25 equals 9 plus b squared. That's 16 equals b squared, and b is 4. So b squared is 4 squared equals 16. So the equation now is already done. We know we've got the a value is over here, the b value is here. It's equal to 1. We know that since this is in the x position, that means it goes over top of the x squared, and it's minus a y squared. So right here, within a few minutes, we came up with the equation for this. Now it's saying, though, that the lamp is 15 inches high. So when we divide that by 2, we want to know when is the y value 7.5. So our equation, put in the desired y value. And when you work all of this out, you should end up with that the entire base, we'll say that the x is approximately 6.375. And since this gives us only half of the dimension, you have to multiply it by 2 to get the rest. So x is approximately 12.75 inches. All right, you won't have to do a lot of that, and if you do, it'll be extra credit. But right now, I want you to just practice, do some of these practice problems, do some of the guided practices. Um, just give it a shot, and we'll do a lot of these in class when I see you next.